Hey there, this is Mr. Thornton, and this is your first lesson in trigonometry. It's all about functions. A lot of it hopefully will be review. We'll be talking about things like domain and range. Some of it may be new, things like interval notation. I think you touched on that last year in Algebra 2. We'll be talking about that quite a bit, and we'll be using that a lot this year. And then we'll be looking at graphs, intercepts, a lot of review stuff. So hang on and we'll get right into it here. All right. If you were able to print off these notes, that would be helpful, and you can kind of fill them in as we go through. If not, just jot down notes as, pause the video when you need to, write down what you need to, okay? So this is an introduction to functions. We start with functions by talking about relations. A relation is, by definition, a rule of correspondence between two sets of quantities. That's it. If we have two things, two groups of things that are connected in some way, we call that a relation. All right? Relation can take the form of a graph, a set of ordered pairs, an equation, or a verbal description. And there's probably other ways, but these are the most common. In fact, sometimes we do mapping. A function is a specific type of relation. A function is a relation in which we assign each x, a relation which assigns each x to exactly one y. So for every x value we have, it's assigned to exactly one y value. No x value can be used twice with different y values. And you probably remember the graph will pass the vertical line test. And we'll talk throughout this, first semester especially, about the vertical line test. And it comes out throughout the year. The x is the independent variable. Also, sometimes we just call that the input. X is the independent variable, the input. Y is the dependent variable. Y depends on x. And that is the output. All right, the domain is the set of all possible x values. Domain generally goes along with x, for which the expression is defined. Set of all possible x values for which the expression is defined. The domain may be determined by the graph or equation. So if we have a graph or equation, it's usually pretty easy to find the domain. The range is the set of all possible y values for a given relation. The range is usually easiest to find from the graph, not from the equation. Okay? It's a whole lot easier to find the range from the graph, not so easy from the equation. All right, so that kind of defines, we have defined relation, function, domain, and range. Now we're going to look at interval notation. And I think y'all used interval notation a bit with Ms. Riddell in Algebra 2, but we will use it almost very extensively this year and almost exclusively. Sometimes we'll use inequalities, but when we're talking about intervals, meaning a group of values, a lot of times we'll use interval notation. It's easier. I think it's a little bit more streamlined. So remember, just a quick review, remember that when we have, these are less than signs that point to the left. We have greater than signs down here that point to the right. And when I say point, I'm talking about the direction that this little arrow kind of goes. All right, so if it goes to the left, it's less than. Goes to the right, it's greater than. And if there's a line underneath, it means less than or equal to. A line underneath this one, greater than or equal to. So when we have the line underneath, we say that that's inclusive. It includes the 3. We're saying 3 is less than or equal to x. Well, that includes the 3. 3 could be equal to x, and that's okay. If we say 3 is strictly less than x, no line, then that's exclusive. It is excluding the 3. 3 doesn't belong in that group. It's all the numbers less than 3. It's all the numbers greater than 3, but not equal to 3. So 3.0001 would be included, but not 3 itself. All right? So when we do interval notation, if we have a little bar there, we use a bracket. Okay? We use brackets for inclusive. We can say this is closed, and it includes the endpoint. All right? If we're using parentheses, we say open. That's exclusive. It's open, and it does not. Do not include the endpoint. And you don't have to have both brackets or both parentheses. Sometimes we'll have one of each. Endpoint here. Talking and writing at the same time, messing up. All right. So when we say 3 is less than or equal to x, less than or equal to 5, we're talking about all values between 3 and 5, including 3 and 5. And so this is going to look a lot like an ordered pair, like the numbers we put in parentheses usually. But since we're including 3 and 5, we're going to put them inside brackets. So what this would mean is all the numbers between 3 and 5, including 3 and 5. Second line here, we want all the numbers between 3 and 5, but not including 3 and 5. So we're going to put parentheses around that 3 and 5. So this is all the numbers between 3 and 5, but does not include 3 and 5. And you can see that looks exactly like an ordered pair. So you need to be very clear on what you're talking about. Are you talking about an interval, meaning all the numbers between 3 and 5, or are you talking about the place on the coordinate system, 3, the x value is 3, the y value is 5, because they look exactly the same. All right, x greater than or equal to 5, that means we want all the numbers starting at 5 and then going up to infinity. So the smallest number in this range is going to be the 5, and I want to include that 5, so I'm going to put a bracket on it. And then it goes up forever, so we're going to infinity. The top is going to be infinity, and anytime we have infinity or negative infinity, we always use parentheses. We never use brackets with the infinities because you cannot be equal to infinity. Here, x is strictly greater than 5, so we're going to start with 5, but with a parenthesis since 5 is not included. And we're going from 5 to infinity with parentheses. All right, finally, 3 is less than x, less than or equal to 5. So we're going to say 3 to 5. For the 3, we will have parentheses. For the 5, we will have brackets. Okay? So let's talk about function notation now. Function notation is simply writing an equation in terms of its function name. So we say f of x equals 3x minus 5. Hopefully you remember that this is basically equivalent to like y equals 3x minus 5. Only we're saying that this is a function. This equation represents a function, and that function we're calling f. So f is the name of the function. It's dependent on x. X is our independent value, so f of x is the y value. You can see f of x becomes the y. Y value, the output for a given x. Okay? So we could say, you know, for this particular one, if my input was 2, then I would say the y value would be 2 times 3 is 6, 6 minus 5 is 1. So f of 2 would be equal to 1, because f of 2 is the y value 1 for a given input of 2. All right? State whether the relation is a function. Always read a graph from left to right as x increases. Okay, you can see on this graph that we have a little arrow on the left end here. It's pointing down and to the left, so we're going to just assume that this graph is just going to continue in some way down and to the left forever and ever. So as far as the domain goes, remember domain are the x values. So how far left do we go? How far right do we go? Well, it's going forever to the left because this is going to continue going down to the left. So I have no left endpoint. It's going forever to the left, meaning it's going to negative infinity. However, at the right end, I do have an endpoint, and that endpoint occurs at x equals 7. So the top value is 7. You notice that that is a closed circle at that endpoint, so that means we are including the 7. We're going to have a bracket on the 7, but always on the left endpoint, we're going to put a parentheses there. For the range, now we're talking about the y values, up and down. Okay? I can see I have a low point right here. It looks like it goes down to -4 here. Is that the lowest point? Well, no, because over here on the left, remember, it's going down forever. So there is no minimum. It's just going down forever. So the lowest point, it's going to go down to -infinity again. And again, I'm going to put a parenthesis on that. I do have a highest point. Again, it's this right end. It goes up to 4. And notice we're using the y-axis here for our scale. It's going up to 4. And that's a closed circle, so I'm going to put a bracket on that. Is this a function? Well, it passes, if I drew a vertical line anywhere on this graph, remember the vertical lines test says if I can draw a vertical line and it never crosses the graph more than one time, then it is a function. And so this passes the vertical line test. Yes, it is a function. Okay, one-to-one function. So we said that functions are a specific type of relation. Now we're going to talk about a specific type of function. We're going to narrow in just a little bit more. A function which assigns each y value to exactly one x is called one-to-one. Okay, so it's just flipping how we defined a function. We said for a function, we assign each x value to exactly one y. If we can also flip that and say, if I have a function, it's a function already, which assigns each y value to exactly one x, then it's also a one-to-one function. In other words, no x value or y value can be used twice. The graph will be a function that also passes the horizontal line test. So if it passes the vertical line test, it's a function. If it passes the horizontal line test, where if I drew horizontal lines, it's never going to cross the graph more than once, it's one-to-one. So clearly, like this graph we just finished with up here is not one-to-one. Okay? That is not one-to-one. All right, x-intercept. This is the point on the graph where x equals 0. Excuse me, where y equals 0. Point on the graph where y equals 0, coordinate's going to be something, comma, 0, because your y value is going to be 0. This is the x-intercept, all right? This is the x-intercept. This is where it crosses the crossing the x-axis. This is also called a root. Often you'll hear this called a root, and it's also called a zero of a function. The root or zero of the function is also the x-intercept. It's where it crosses the x-axis. Y-intercept is the point on the graph where x equals 0. And this is crossing the y-axis. And the coordinates will always be 0, comma, some number. A function is increasing on an interval if, as x increases, y increases. So if we're moving from left to right, as x increases, that means we're moving from left to right, then the y is increasing, it's going up. So for example, over here, this is increasing over here, this is increasing here. So I'm moving from left to right, the graph goes up. Decreasing, a function is decreasing on an interval. Hopefully I can see this. Decreasing on an interval if, as x increases, again, notice we're always defining this in terms of an increasing x. We're moving from left to right. The y decreases. So I'm moving from left to right. As x increases, the y is going down. So this would be, back on this graph, in this vicinity right here, this is where it's decreasing. All right? And finally, a function is constant on an interval if, as x increases, moving from left to right, y stays the same. As x moves from left to right, y stays exactly the same. So, just a little sketch here to show you what we're talking about. If I have a coordinate system, then here it would be increasing when it's going up, it would be decreasing where it's going down, And this is where it's constant, where it's exactly stays the same. Y does not change, it just stays the same. Okay? Okay, so page 3, we're analyzing the graph here we're given. We're going to go through this fairly quickly here. So first of all, is this a function? Well, it passes the vertical line test, right? Anywhere I draw a vertical line, I'm never going to hit the graph more than once, so we're going to say yes, this is a function. Domain, x values, left to right. So the farthest left I go is -4. The farthest right I go is 9. Notice at -4, I have an open circle, so that is not included. I'm going to put parentheses there. At 9, I'm going to put a bracket because I have a closed circle that is included. Range. Okay, up and down now, the y value. My lowest point on any of this graph is right here, and it tells me in parentheses here that that y coordinate is -3.5. So that's my minimum. The highest it ever goes, I have a pretty high point here. This is a relative max, but it's not the highest point because I have a higher point over here to the left, and that point is 5. The -3.5 has a bracket because that's included, but the 5 has an open circle. We'll put parentheses on that. What is f evaluated at 3? So what is the function's output when x equals 3? So I go on the x-axis to 3, and I say, what's my y value on the graph? Well, the graph is down here at y equals 3, x equals 3, and my y value is -2. So f of 3 equals -2. Where is f of x equal to 3? So where is, when the y equals 3, remember f of x is y. So when y equals 3, the question is what's my x value? So if I go on the y-axis up to 3 and find the graph, well, I've got a point over here, and then to the right I've got a point over here. So I've got 2 different x values that give me y values at 3. One of them is x equals -3. That's going to be the first as far as going left to right. And then the second one would be x equals +6. What is f of 0? All right, my x value is 0 here. Remember, this is f of x, so my x value is 0. What's the y value? When x is 0, I'm on the y-axis, so I'm looking at this point right here, and that point would be -3. f of 0 equals -3. Where is f of x equal to 0? Notice anytime I'm looking for x values, usually at least, it's going to say where. Where is this? Where is that? What is the interval? Anytime it asks for intervals, we're looking for x values. Where is f of x equal to 0? All right, if my x value is 0, if my y value is 0, I'm on the x-axis. I've got 3 x-intercepts here. So one of them is -2, x equals -2. X equals +4, x equals +8. Where's f of x greater than 0? So where's the y value greater than 0? Well, y is going to be greater than 0 anytime I'm above the x-axis. So basically it's asking, where's the graph above the x-axis? Well, all of this first little tail over here to the left is above the x-axis, and that is my interval from -4 to -2. So that's my first interval. It does not include the -4, so I'm going to put parentheses there. And since I'm saying strictly greater than 0, it does not include the -2 either. So from -4 to -2, and then it goes below the x-axis for a while, and then once I get to 4, to the right of 4 it goes above until I get over here to 8. So 4 to 8 also above. And notice I'm using parentheses because I'm not including those points. Those points where it's equal to 0, but I don't want to know where it's equal to 0. I want to know where it's greater than 0. X-intercepts, number 9. We already talked about that. They're at -2, 4, and 8, but when we're talking about x-intercepts, let's write those as ordered pairs. So now these are ordered pairs, not intervals. -2, 0, 4, 0, 8, 0. I've got 3 x-intercepts. I've got 1 y-intercept, and that would be at 0, -3. Is this 1 to 1? Well, we said it was a function, so it passes the vertical line test, but it does not pass the horizontal line test. If I draw horizontal lines, I have a problem. Not horizontal. Give the intervals where f is increasing. It's going up from left to right. Okay, so hopefully you can see this, that starting at this point down here, I've got a minimum, to this point up here where I have a maximum, that's going to be increasing. All the way between those two, it's increasing. Now it's curving some, meaning it increases at different rates, but it's increasing the whole time. So from 1.1 to 6, and notice I'm using the x values, 1.1 to 6, I am increasing here. From 1.1 to 6. Where is it decreasing? Well, it's decreasing to the left over here. So that's going to be from -4 to 1.1. At -4 is my high point up here, all the way until it gets down to 1.1. It keeps on going down. So -4 to 1.1, and then it increases for a while, and then it decreases here on the right end. From 6 to 9, it's also decreasing. Now I'm putting parentheses here because we would not say at one point, just at one point it's going to be increasing. So I'm not going to include 1.1. All right? That's where it turns. 1.1 is my turning point, but it's not strictly increasing there. So anytime I'm putting these increasing, decreasing, or constant intervals, I'm always going to use parentheses on these. We are talking about intervals. This is interval notation, not ordered pairs. But I'm always going to use parentheses on increasing, decreasing, constant intervals. I don't have any constant intervals. There's never a place in here where it's flat, where it's just going straight across. So this is not applicable here. No answer there. All right, number 15 here. Where is f of x equal to -2? So that's where is y equal to -2? Where on the y-axis I find -2. And I can see I have a point here just to the left. I have a point just to the right. And be very careful, I've also got one last point way over here to the right. So I have 3 different values here. So I've got x equals -1, because that's my x value of -1. I've got x equals 3. And then finally, way over here, I've got x equals 9. I've got 3 values here. Now, take a few minutes. See what you can do with this next graph. I'm going to pause the video. When you come back, we'll kind of I'll have the answers written. You can check yourself. Okay, so here are the answers for 16 through 30. I'm going to talk about a few of these that I circled here. First of all, domain. You might have looked at this and said, well, it goes forever to the left, it goes forever to the right, therefore it must be all real numbers. The problem is we've got 2 kind of weird places here. The first is right here at -3, where we have a circle. So it does not exist at -3. The function itself has no value at -3, so it does not exist there. That is not part of the domain. The second weird place is right here where we have a break and it's discontinuous. So the question is, does it exist there? Well, yeah, we have a closed circle for x equals 2. We have a closed circle up here on this end. We have an open circle here, so that is not, this point is not part of the function, but this point up here is. And so it goes from if we're heading from the left, it goes right up and it exists here at x equals 2. And then as soon as it gets to the right of 2, it jumps down here. So that's okay. We're okay with this, but it does not exist at 3. So instead of -infinity to +infinity, we have -infinity to -3, parentheses, meaning it's not included, and then -3 to +infinity, again with parentheses to show -3 is not part of the domain. For the range, again, this one's a little weird. It is not going down forever. Clearly, this arrow going off to the left is on this line of, 3 down on the y-axis, and so y is equal to -3, as far from starting at x equals -4 and going to the left, y is always going to equal -3. To the right, it does go up forever, okay? So the lowest point we can possibly have for a y value is -3, and it does equal that, because that is a solid line there, so I've got a bracket on -3. to positive infinity. Okay? Number 23 at the bottom, where's f of x less than or equal to 0? Well, and I justified this right below it. Justify your answer number 23. F of x is less than or equal to 0 when the y values are below the x-axis or on the x-axis. It says less than or equal to. It can be on the x-axis as well. So where is it below the x-axis or where is it on the x-axis? Well, you know, again, I messed this up. So it's below the x-axis from negative infinity until it gets to negative 1, except at negative 3. So this is not quite right. Let me change this. This should be from negative infinity to negative 3, because it stopped and negative 3 doesn't exist. And then from negative 3 to negative 1, again, it's still below the x-axis. And this time I'll put a bracket on negative 1, because equal to 0 is okay. We want to include that point. All right? And then once again, I'm going to include the point 4. It's equal to 0 at 4. Yeah, all right, it's equal to 0 at 4, and then it stays below until it gets over here to 8. All right, so all that part over here from negative 4, from positive 4 to positive 8 with brackets, that's also inclusive. All right, next thing I want to talk about, number 28. Where is it decreasing? Some kids have trouble with this. Clearly, it's going down from 2 until it gets to 6, and then it's also going down from 6 to 7. It just changes very abruptly right there. Okay, so the rate changes, the rate at which it's decreasing, it's linear until it gets to here, and then all of a sudden it changes speed. But still, it's decreasing that entire thing. From 2 to 7, it is decreasing the entire time. And then, last one, find f of 2. 2 is where we have this discontinuity. So if I said, what is the value of the function at 2? Well, since I have an open circle here, I'm not counting that. I have a closed circle here, I am going to count that point. And so f of 2 is equal to a positive 3. Since the y value for that point is positive 3, then f of 2 is equal to 3. Okay, if you have any, hopefully you got the rest of these right. I hope that explanation was helpful to you. This is a pretty long lesson. If we ever have lessons longer than this, I'll probably split them up over 2 days. But this is kind of right on the edge of one is, you know, do it in 1 day or try to split it over 2 days. And so I try to force it all in on 1 day here. But most of the lessons are not this long. You'll have some practice problems to work to show me that you understand this. And then we'll move on to other stuff. We'll be dealing a lot with functions over the next couple weeks. Okay. I'll probably have some kind of instrument for you to give me some feedback about how well you understood this, or if you have any questions. So let me know about that. Okay, we'll talk to you later. Bye-bye.